The mission of this demonstration is to simulate in real time the capabilities and advantages on how to achieve the best security in the next generation software-defined data center. The demo will consist of 3 scenarios or use cases. First scenario demonstrates feasible and scalable microsegmentation. The second scenario demonstrates automated and agile security provisioning. And the third scenario demonstrates advanced security seamlessly embedded into NSX as DDC. So let's get started. In my demopoint environment, create a demo environment respective of your audience. Select the vsec NSX demo as shown. Once the environment is ready, you will see a timer showing the availability of the demo environment. For this demo, we will be only connecting to 1 out of the 4 virtual machines, called vCenter server. If the connection to the VM is unsuccessful or you disconnected from it, please reconnect using the reconnect button. For better graphical performance, we are going to connect to the VM through the RDP client as shown here. The passwords used are listed in the cookbook for this demo and available from the 5th tab called Cookbook. Before you start the demo, please check the date and time of the vsec gateway and the VM you are connected to. To do this, open the vsec gateway shortcut on the desktop. Once the terminal session is established, go into expert mode and execute the date command. Compare the time and date with the local VM time and date. If they are not the same, check the N2P time settings on the VM by going to the control panel, date and time, go to the Internet Time tab and change the settings. If the time.windows.com server doesn't work, select another one from the list and click Update Now. When successful, close all the control panel windows and go to the vsec gateway window if it is still open, or restart the vsec gateway shortcut from the desktop. Run from Clish in expert mode the following commands: set NTP active off and then set NTP active on. Wait a few minutes and check the date and time again. If the time and date are the same on the vsec gateway and the VM, then you're good to go. Let's start with demonstrating microsegmentation. In this section, we will show how easy and seamless it is of implementing virtual zones without having to maintain it with IP addresses. Open Smart Console and log in with the provided password. On the right, show the connections to the data center servers by going to Servers, Data Centers, double-click on one of them and show the trust and connection status. Close the open window and go back to the security policy screen. To show the ease of adding the available objects from those connections, we will go to Rule 6, which allows access from web group to DB group. Select the source field and click on the plus to add another object. Select Import at the top right and select NSX to show the available groups. Point out that the web group object in Rule 6 was pulled from this list. As we demonstrated the ease of adding objects from the NSX environment, you can also mention that pulling objects from other environments, such as Microsoft Azure or AWS, works the same way. Close the Open Object window and minimize Smart Console. Now we're going to review the NSX groups used within the security policy. Open the Google Chrome shortcut. Within Chrome, you will be using vSphere Web Client. Click on Login. Navigate to the NSX section called Networking and Security. Go into Service Composer menu and review the groups that are listed there. The vCenter machine that we are on now, at 10.0.0.9, and a web server at 10.0.0.101 are on the same subnet. The following steps will show that the vsec gateway protects the traffic between these machines, demonstrating east-west protection. In the Chrome browser, click on the web link Web Test. This will use port 8080 to connect from the vCenter machine to the web server. Switch to or open Smart Console and click on Rule 2, or go to Logs. You might have to refresh the logs before you get to see the traffic matching Rule 2 was accepted. Now go to Desktop and open the PuTTY shortcut Web. This will start an SSH session with the web server. Connection should be accepted by rule number 2. Go back to Smart Console and check the logs. Refresh if needed, or go to rule 2 and find associated logs. To summarize, we have demonstrated the ease of creating microsegmentation within the virtual zone. Policy enforcement was accomplished by pulling objects from NSX. For the next step, we will be demonstrating dynamic enforcement, keeping tight security without breaking network elasticity with agile security provisioning. This means Checkpoint vsec will continue securing virtual machines as they move around the SDDC. The vsec gateway, managed by SDDC Aware Management, is capable of adapting to rapid changes automatically and in real time. To demonstrate this, we will be making some changes to VM objects showing the ability of the security solution to follow automatically. In the Chrome browser, go to the vSphere web client. After logging in, review the menu options to get familiar with the VMware options. From vSphere Home section, go to Networking and Security. Then go to Service Composer and click on Security Groups, which is the first tab within the window. This menu will give you insights into which VMs belong to each VM group. Go to the Web group and within the Virtual Machine column, click on the number 1. This will open a list of VMs belonging to this group. You see that Web Server 1 VM is part of this group. In real life, you could see many servers listed. To update the list, press on the refresh button at the top of the window. Default refresh value is 30 seconds. In the Security Policy Rule Base, review rule number 6, which allows MS SQL and ICMP from the web group to the DB group. When working with vCenter and NSX, Checkpoint Security Management will implement the rule base accordingly, so the VMware business logic policy is if the VM name starts with DB or web, they belong to the appropriate security group. So if a server is not part of the correct security group, they cannot communicate. To show communication between the web and DB machines, we will open an SSH connection to the web server and run a few scripts. On a desktop, open up the PuTTY shortcut called web. You will be logged in automatically. Type ls to see the contents of the home directory. As the first test, execute the connection test. This will send an ICMP to the DB server and should be accepted by the security policy. Now execute the SQL query script, which sends an SQL query to the DB server. Again, this should be accepted by the security policy. Switch to or open Smart Console and review the logs from either Rule 6 or from Logs and Monitoring. Select one of the entries and double-click to see the full details. You will see that against the source, we also see the object that was used in the policy. In this case, it was a member of the web group. To show dynamic changes inside the data center, we are going to change the IP address of the web server, which currently is 10.0.0.101. Switch to or open Chrome and go to the vSphere web client. From the home screen, select Hosts and Clusters. Select Web Server 1 and open the Summary tab at the top. Verify that the IP address of the web server is 10.0.0.101. We're going to change the IP address of the web server. Open the PuTTY shortcut Web from your desktop. You can do an ls again to see its contents. Now run the change IP script, which will change the machine's IP address to 10.0.0.99. Since you are logged in through a different IP address, you will notice that the SSH session will time out. Go back to Chrome and vSphere web client and review the Summary tab. Verify that the IP address has changed. If it hasn't, use the refresh button. Changes may take up to 30 seconds. To show the changes within the security policy, go to Smart Console, Rule 6, and click on the source web group. Hover over the IP address to reveal that the IP address has changed in the policy as well. Now go back to the desktop and open the PuTTY shortcut. Fill in the new IP address of the web server, which is 10.0.0.99, and connect. Use the username root and provide a password from the cookbook. Run the connection test in SQL query scripts again to show that connection is still up and accepted by the security policy. Open Smart Console and show in the logs that the connections were accepted. We have shown that NSX components were updated dynamically and that enforcement takes place according to group policy. We demonstrated that in a dynamic environment, security can be kept tight, while IP address is changed without having to modify or install the security policy. This is very important, not only from a security enforcement point of view, but also from the visibility side, where the logs are displaying a consolidated view of the packet, not only based on the IP address, but also on the group and name details. It is optional to revert the IP address back. Run on the web server the revert IP script. Verify in vSphere web client that the IP address did change back. Important to note is that IP modifications on NSX usually take effect within about 10 seconds. As a next step, we will demonstrate the server name modification and how the name follows the NSX security group logic. First, let's review within vSphere web client the NSX group, networking and security. Select Service Composer. Check that the web group includes one VM object called Web Server 1 by clicking on the number 1. To review the security group, right-click on the web group, select Edit, and select the second option, Dynamic Membership. You notice the criteria showing that VM names containing web will be part of this group. Close the window and go back to the home screen. From there, select Hosts and Clusters. Right-click on Web Server 1 and select Rename. In the name field, change the name from Web Server 1 to Generic Server 1 and click OK. In about 30 seconds, NSX will update the vsec gateway about the change. From the summary page of the change server, open the remote console and run the connectivity test in SQL query scripts. Press Ctrl and C keys to interrupt the script after a few seconds, as connections are not possible. You will see there is no response as the traffic will be blocked by the vsec gateway according to the policy. Go to Smart Console and check the logs. You will see that traffic between the generic server and the DB server are now blocked. Go back to vSphere web client. Go to the home screen, Networking and Security, and select Service Composer. You will see that there are no VMs part of the web group any longer. To complete the scenario, change the name back to Web Server 1 and run the connection test in SQL query scripts again from the Web Server console. Going back to Smart Console, you will see in the logs that both connections were accepted. We have seen a dynamic enforcement scenario where vCenter and NSX dictate the group membership and the vsec gateway enforces it in a virtual zone. Another useful scenario is applying templates from the vCenter to be automatically enforced according to business logic. This is a great method to provide ease of operation and provisioning security groups according to company's policy. In a third use case, we will be showing advanced security embedded into SDDC with threat prevention using NSX auto-tagging. First, we will have to check to see if threat prevention, specifically anti-bot and antivirus software blades, are turned on in the vsec cluster. In Smart Console, go to Gateways and Servers and double-click on the vsec cluster. IPS, anti-bot, and antivirus should be selected. Close the window and go to the security policy. Review rule number 4 and 5. The infected VMs group will interact with NSX and block any malicious activity within the data center. Open Chrome and go to the vSphere web client. Go to Networking and Security section and select Service Composer. Check that within the infected VMs group there are no VMs listed. Go back to the main screen, then Hosts and Clusters, and select the Web Server 1. Within the summary window, make sure that the security tags list is empty. Now we are going to simulate command and control traffic from the web server. On the desktop, open the PuTTY shortcut called Web. From the command line, run the script to propagate a bot. The attempt to communicate to the command and control server should be blocked by Entobot and listed in the logs. Go to Smart Console and open the logs. The first log entry is the prevention of communication by the Entobot blade. The second log entry is the vsec tagging, which indicates that a security tag was successfully assigned to a specific VM ID within NSX. The third and fourth logs are from identity awareness, indicating that the infected VM was logged into the infected VM group and logged out of the web group. Go to vSphere Web Client, Hosts and Clusters, and click on Web Server 1. In the Summary tab, you will see that the VM now has the infected security tag. Go back to the home screen. Go to Networking and Security and select Service Composer. You will see that within the infected VMs group there is now one virtual machine. Click on the number 1 and verify that it is indeed the web server VM. Open Smart Console and go to the security policy. Review rules number 4 and 5, which will block all traffic from and to the infected VM security group. To show this, open the PuTTY shortcut Web, and from the command line run the SQL query script. Go back to Smart Console and open the logs. Refresh the logs and show the blocks. As a last step, we are going to release the VM from isolation. Go to vSphere Web Client. From the Networking and Security section, go to NSX Managers, which is towards the bottom of the list. Select the Manage tab, and within the security tags, right-click on the Checkpoint Bot Found security tag. Click on Detach Security Tag. A list of VMs with the tag will show up. Select the VM you want to detach the tag from and move it to the right. Click OK, and you're done. Verify that within the security tag list there are no VMs associated any longer with the infected tag. As an extra step, you could also show the summary screen of the VM where tags are listed. You should see no tags there. We have seen how Checkpoint threat prevention components detected malicious activity within the virtual data center by implementing lateral traffic inspection. Checkpoint triggered immediate communication updating the NSX components that inserted the infected VM to quarantine. Checkpoint will automatically block all connectivity from and to that VM, allowing administrators to remediate the infection. So now we have come to the end of the demo. Please remember to suspend the environment once you are done. Thank you very much.